Welcome to Secret Spaces, everybody. Thanks for coming. This is a weekly Twitter space featuring Secret Network contributors and news from around the ecosystem. This week, we are discussing the network upgrade that happened last week, Secret Network version 1.9, which we named IBC v4 plus Secret VRF, as those are two of the main features that are included in this upgrade. But there's a few other things in there as well, like gas evaporation, execution finalization, and IBC emergency button, which are some various privacy and security features. So we'll be digging into all of those things in this space. But first, let's go ahead and introduce our guests. And let's start off with Asaf from Secret Labs. Go ahead, Asaf.
Yeah, hi guys. I'm Asaf Morami. I'm a developer with Secret Labs, and that's it, I guess.
All right, thanks, man. And let's go to Sean Rad.
Hey everybody, my name is Sean Rad. I do developer relations for Secret Network. Super excited to be here. We're coming off of the first Secret Hackathon, Hack Secret, which was a month-long hackathon that just happened. And I see some of the developers from the hackathon here, so it's great to just see the community here right now, and excited to talk about the network upgrade that Asaf was a huge part of. There's a lot of exciting new features we're going to touch on today.
All right, and Star Shell Wallet.
Hey guys, Blake Subdoggy here, and just we contributed a small privacy feature to the upgrade, so I'll be here today to expound on that.
Awesome. Thanks, guys. All right, so we went ahead and covered the basic features that are included in the network upgrade, but let's go ahead and dig into each of those, starting with IBC v4, as I think that's probably, we won't say the most important, but it's definitely one of the biggest features with the most new features included that come along with that, because it kind of has its own subset of features underneath it. So it's a brand new version of the IBC protocol. I believe it bumps us from, I think we were on 3.4.0 before, and it bumps us to 4.3.0 maybe. It's a whole new version, and two of the major new features that come along with that are packet forward middleware and fee middleware. So whoever wants to take it first, maybe Asaf would be the first person to start us off. Let's talk about packet forward middleware and what that is and how it works.
Yeah, so basically IBC-v4 adds the ability to use middlewares on IBC apps, which means that we can use modules that catch packets before they go into a secret network or after packet is transmitted by an app on secret and before it leaves the network, and do some cool stuff on that packet. So packet forward middleware is a middleware by Strangelove. The whole goal of it is to unwind the IBC denom. So if you're familiar with it, it's been a pain in the ass to transfer tokens seamlessly between chains, because if I transfer, for example, Atom from the hub to Osmosis, and then I want to transfer it from Osmosis to Secret, then it's not that straightforward because of how the transfer app works. On the hub, it remembers that Osmosis owes a certain amount of atoms to the hub. So then if we transfer it to Secret, then we need to remember like two debts, one to Osmosis and one to the hub. So what we've been doing up until now is just connect every two chains together, and then we say that the canonical atom is the one that's coming straight from the hub, which is annoying for users because to send atoms from Osmosis to Secret, you have to go through the hub first, which means you have to send two transactions, one on Osmosis and one on the hub. So the packet forward middleware allows us to send just one transaction on Osmosis, and then on the hub, the packet forward middleware can route the packet to Secret directly. So maybe after I've said all of this, I'm thinking like the hub is not a good example because they don't have it yet, but most of the other chains do have it. So for example, the Osmosis and Juno, you can route Osmo and Juno seamlessly, and now Secret seamlessly through IBC. Yeah, maybe a bit of rambling here, but hope it was clear.
Yeah, it makes sense to me. So I guess just to put it simply, it simplifies the routing of IBC packets. So instead of having to do two separate transactions, if you want to move something from one chain to another and it's not a native asset on that chain, instead of having to do two different transactions, it just does one transaction.
Yeah, maybe more specifically, it simplifies the movement of secret in the interchain.
Right. Secret specifically.
Yeah.
Cool. Well, that's packet forward middleware. How about fee middleware? You want to tell us what that is, Asaf?
Yeah, the fee middleware is, maybe let's put it like this. It's the beginning of a fee market on Cosmos. And it allows a transaction sender to also specify a fee to be paid to the relayer and for forwarding IBC packets. Nothing more than that. Like it's very raw,
Simple,
I
but
would say. Yeah.
it's simple, but it's definitely an important feature to have because up until now, IBC relayers pretty much had to just operate kind of on charity. They had no way to, at least they had no way to directly set fees for their services. So a lot of times it's just large validators that have other reasons for wanting to provide that service. Maybe they already have a large stake in that chain, so they want to see it grow. So they're just providing IBC relaying kind of as a free service, a public good. And this fee middleware makes that a lot more economically sustainable for them to keep operating. I know some of our secret IBC relayers are sometimes they're small teams, and they can't just keep running for free forever. So I think this is a great feature that will allow them to keep providing that service. And it's a super important service because that's what runs the IBC protocol. What allows tokens to move back and forth between chains is these relayers.
So it's like a Ticketmaster convenience fee.
Which sounds bad, but it's good because we really do need that.
Nice.
Because they can't just operate for free forever. As nice as that would be for users, I guess it's not reasonable for us to expect them to do that.
Yeah, and now we just need the tooling to catch up with that feature.
Yeah, so what would that look like from a user's point of view when I guess they would initiate an IBC transaction and then that fee would automatically get added to the transaction?
Sort of. It's still not that convenient. Like UIs have to craft the transaction in such a way that you have to send. Maybe I'll go back a bit. Every Cosmos transaction is an array of messages. Like you can send multiple messages in one transaction. So, for example, a message can be a transfer of funds, and another message is executing a contract and stuff like that. So to send, so with the fee middleware, we get new message types. So you can like specify a fee for an upcoming packet. It's kind of weird. Yeah. You need to specify the fee in a message, and then in the following message, you have to send the IBC packet.
Would it be like two separate transactions that the user has to approve?
No, it's one transaction with two messages inside of it, but UIs for now UIs have to like craft that transaction in such a way to enable the fee. And then I'm not sure if there's even a place to check what fee should you use, what fee figures you should use, and like I'm not even sure that relayers can modify their setup to not route packets based on like if the fee is low or something like that.
Got it. So there's still some things to figure out as far as the user experience.
Yeah, but we're getting there.
Cool. So packet forward middleware, fee middleware. Let's move on to the next major feature, which is Secret VRF, which is probably it's the one I'm most excited about, as it's a example of privacy as a service, which is something that we've been talking about for a while. This is a live, ready-to-use example of privacy as a service. And so what it does is it provides random number generation. And it's not just for Secret, but it's for the entire IBC ecosystem, which is what makes it privacy as a service. So, Asaf, you want to just give us a little intro to Secret VRF?
Yeah, that's also like the feature that I'm most excited about. Basically now, on every contract invocation, the contract also gets access to a random number seed, I would call it, and then the contract can use it immediately to initialize like a pseudo random number generator and do whatever it wants with it. That maybe sounds simple, but up until now, you couldn't do something like that. You would need to somehow bootstrap your own entropy pool, which translated into like users have to send a bunch of transactions before they were able to start to interact with the contract. So now what we are doing is generating a random number seed for each block inside of SGX. Like the proposer of each block generates a strong random number and then puts it in the block header, and then all other validators can verify that the random number was generated inside of SGX, and then they approve the block. And then when a contract is invoked in that block, we do a couple more manipulations on that number to make sure that for every contract call, there's a unique random seed that's being passed into that contract. And that's basically how it works. So it sounds boring when I say it, but when I said it just now, but what it opens up is a whole new world for like gaming. You can do lotteries with it, anything that you need, and unpredictable outcomes, like to make sure that things are fair, authentication protocols, which require sometimes random numbers and stuff like that.
Yeah, so basically it provides a service that's otherwise hard to obtain in a decentralized manner, at least. It's something very commonly used in the Web 2 world, and it's something that's essential for a lot of applications, but it's a hard thing to achieve on a blockchain for technical reasons. I just pinned a blog post at the top of this space. If you want to check out all these features that we're talking about, there's a blog post that goes into a lot more detail on each one if you want to read that afterwards. But yeah, just to put it simply, it's providing something in a decentralized way that's otherwise hard to achieve on a blockchain. And it's also doing that in a secure way because of the trusted execution environments and Secret Network allow you to generate that number confidentially. And if you want to just keep that number that you generate completely confidential, if you're a developer and maybe you're designing a dApp and for whatever reason your design requires you to keep that number private and not even reveal it to users, you could do that. And this service is also available to developers on other IBC chains as well, which allows them to generate random numbers securely and decentralized, but it will be public once it leaves Secret. That's just the nature of, public blockchains. Once it leaves Secret Network, that number will be visible on the chain that's receiving it, but still very useful for them to be able to receive a random number like that and make use of it and all those different things that Saf just mentioned, gaming, lotteries, potentially other things like DAOs that might need to randomly select users or assign tasks, or maybe if you're building some kind of security protocol that maybe it needs to pull a random number to generate like a seed or a recovery phrase or some kind of authentication key, something like that. A lot of different possible uses for random numbers. Asaf, you go ahead, and then Sean, if you wanted to add anything to that.
Yeah, so if you're going to use it on Secret, then that's the best experience that you'll get in crypto. And then if you want to use it on another IBC chain, you can request a strong random number from secret, and then it will be public once it leaves secret until it reaches like the chain A, but there's gonna be like 20 seconds that cheaters, I would call, can intercept the random number between when it leaves secret and then when it reaches chain A. But still, that's, I guess, the best experience that you can get on public chains too. So that's progress.
Yeah, I just want to emphasize how elegant the solution is that Slabs designed. Like what's happening during Tendermint consensus, the random number is being like Trojan horsed into Tendermint, and it's attached to the proposer node's block, and it's extremely elegant if you want to use it in your smart contracts. Like I just linked the docs below on the secret spaces, and all that we're doing is just pulling the environment variable. So it's as simple as just, you have your environment parameter, and then in your smart contract, all you do is access the environment variable. Like in a single line of code, you can have your random number. So if you want to see what that looks like in a smart contract and be able to just like clone down a contract and play with it and start in your own contract logic, that all exists in secret docs right now. And there's also an implementation of what it would look like on IBC. Right now, the example uses IBC between two local secret containers, but we're working to have it so that we'll have an example of IBC with the randomness API between Secret Testnet and Juno Testnet to see the full capability of what you can do with this. If anybody has any questions about that, or if you run into any issues going through the docs, just ping me here or on Discord, and I'll be sure to get back to you and make improvements.
Awesome. So if you're a dApp developer on an IBC connected chain, you can make use of Secret VRF right now just by checking out that blog post above. And there's links in there that will take you to the documentation that Sean just mentioned. And we'll also be doing a standalone announcement for Secret VRF later this week, which will include its own landing page. So it'll make those resources even easier to find in the main part of the Secret Network website. So if you're an IBC developer, definitely check that out. And I think it's also worth mentioning that eventually we could probably see this service being used over other cross-chain protocols like Axelar GMP, and that would allow it to be used by EVM chains as well. I'm not sure how far off that is.
It should be very easy to, just like the same way you would use it on an IBC chain, you would be able to use it on Ethereum.
Awesome. And you think Axelar GMP is probably the way we'll see that happen?
Yep, in the next upgrade, probably.
Awesome. Okay, cool. Well, I think that covers Secret VRF. Like I said, keep an eye out for that announcement later this week. We'll be putting out a landing page just for that. And let's move on to gas evaporation now, which I know Blake would like to talk about that. Gas evaporation is basically an enhanced contract privacy feature. And I'll let Blake tell us exactly how that works.
So it's evaporation is a name I came up with to give sort of an analogy for the consumption of excess gas that is sent into the execution of a smart contract message, because burning is already used to refer to, like the burning of an NFT or the burning of tokens. But essentially what it is you're intentionally consuming gas, and the reason for that is to protect privacy. So kind of give an overview of how things work a little bit. So there's actually two concepts that are folded into this new API feature. So it's gas tracking and evaporation. And so quick refresher on how gas works in Cosmos chains. When you broadcast a signed transaction to the network, you attach a fee to that transaction. Cosmos calls this fee gas. But unlike how gas works in Ethereum, if you overpay a transaction fee on Cosmos, that difference is not refunded. So after a transaction is executed by the chain, after it's minted into a block, a publicly visible field is attached to every transaction results metadata called gas used. And what that essentially says is how much gas was consumed during the evaluation of all the messages contained within that transaction, as opposed to the gas that was actually provided by the user. So there's usually a difference because you need to provide at least as much gas to cover the execution of those transactions. So you usually end up overpaying a little bit. And by the way, these fees go to whichever validator ends up winning that block. So the COSM-WASM module, which in Cosmos SDK terms, it's just a module. When a user executes a contract, COSM-WASM will go through the program one instruction at a time. Each one of those instructions consumes a finite amount of gas. And after each instruction, COSM-WASM is checking if the consumed amount, the cumulative consumed amount, has surpassed the amount of gas available that was provided. And if that happens, execution fails. If the execution does complete, then COSM-WASM basically hands control back over to the rest of the Cosmos SDK and or the network in this case, so that it can finish processing the rest of the transactions, which may or may not include other messages. So, like for example, a single transaction, you can have two messages. The first one executes a SNP withdrawal, and then the second message executes an IBC transfer. And so you need to provide gas for, the first message, and then the remaining gas hopefully will be enough for the second one. So on Secret Network, the smart contracts actually execute inside of a special hardware unit called an enclave, a trusted execution environment, which essentially allows a piece of code to run inside of a black box. However, the moment that a node finishes processing a smart contract execution message, information, as in the current state of the secret network, information has now leaked out of the enclave about the sum of gas consumed by the exact sequence of instructions that executed inside the enclave by COSM-WASM. So what evaporation does is it provides new API available to smart contracts that will essentially it will use that same mechanism that COSM-WASM uses to meter and consume gas to essentially just consume the rest of the available gas that the execution of that smart contract message has available to it. So this kind of, what this does is it solves a privacy problem, but it also sort of creates a new potential problem, right? So before you could maybe, like, let's say that you have a smart contract that you want to preserve your privacy. You don't want it to show you how much gas was used during your execution, because otherwise someone looking at the gas used metadata can very easily distinguish between SNP transfers versus SNP viewing key creation versus many other types of smart contract execution messages, right? The problem with gas used is that it basically can reveal the nature of your message. So now let's say that you have a smart contract that takes advantage of this new evaporation feature, and it simply just consumes all the rest of the gas that was given to it. Well, if you do that by default, you will not have any gas left over for your next message. Now, for the most part, this is okay because most people just have one execution. Like they're just signing transactions with a single contract execution message. But for more advanced users, maybe they need for, or even for like a DEX swap, right? You need to be able to have multiple executions in a single transaction. So what we're working on is a SNP, a new SNP that basically allows users to provide a field, an argument to every execution that says only consume up to this exact amount of gas and always consume that exact amount. So what you can basically do is you're telling the smart contract to evaporate up to a certain limit, even if it doesn't end up using all of that. That way you get a consistent amount of gas used out of every single one of your executions by simply telling it how much to use. And what that does is that it basically prevents that information from leaking out of the enclave now. Because that consumption happens within the enclave, that information is now all private. And so to an outside observer, they can no longer tell what the nature of your execution was. They don't know whether it was a SNP transfer, something that cost maybe 60,000 gas, or if it was something, way more simple, like a view and key, and only costs 40,000 gas. So that's what the evaporation API is. I'll check back in with our host and see if I can also briefly talk about gas tracking, which is really cool.
Yeah, so let me quickly summarize, maybe simplify a little bit. So basically on Secret Network, whenever you initiate a transaction, although the contents of it are encrypted, you can still see that a transaction took place. So basically it shows that your wallet interacted with a contract. Although that's all it shows, you might not know what was inside that transaction, but you can see how much gas the transaction used. So if you have a certain contract, let's say a DEX, and it has a few common transaction types like swapping or providing liquidity or maybe voting on a governance proposal for that DEX. If you were to analyze a list of transactions and you looked at how much gas each one used, you would see a pattern based on the type of transaction taking place. So you could say, I see that this wallet interacted and used this amount of gas, so I think this is what transaction was taking place, which is, for some people, that's probably not a big deal, but it is data leakage, and you can kind of assume some things about that transaction or that wallet based on the transaction is taking place. And what this gas evaporation feature does is it makes sure that all transactions use a consistent amount of gas so that data, there's nothing to analyze. Like all the transactions just look like the exact same transaction. Is that a way to summarize it, I guess, Blake?
Yes. Yep, that's right.
Cool. And yeah, you said gas tracking was something else you were looking into?
So the way that this API works is that smart contracts can basically just check how much gas they have consumed at any point during execution. So up to this point, how much gas has been consumed. The other piece of information that they have with the upcoming SNP we're working on will be how much gas the user wants this execution to be limited to. So with those two pieces of information, what a contract can do is basically calculate how much excess they have. So after they finish, the core of whatever the message's intent was, they can then check, I have about 20,000 extra gas laying around, like during this execution. I could just return now and consume the rest of that gas, or I could actually do something with it. And so what this is called is opportunistic execution. It's a very interesting use case. So what this means is that contracts can opportunistically perform like housekeeping during that window. So for example, let's say you have an NFT minter, and you also have like a bidding process where the price of the mint is dynamic, and you allow people to bid over time, and based on the time and the amount of the bid, a person's bid may actually result in a mint, within that same execution. So with opportunistic execution, what you can do is basically, as the person makes their bid, if they are currently like the highest bid and your contract logic decides that this bid is actually it's going to win, and there's enough gas left over, you can now go ahead and mint that bidder's NFT within the same message. Whereas normally the only thing the bid needs to do is just lock in that person's bid. Doesn't need to mint it. But with the opportunistic execution, you can now check, I actually have enough gas to also do this extra thing, and then go ahead and execute it. So that's what the one really interesting use case with tracking is, the opportunistic execution. But essentially that's, it's just those two pieces of information being used in an interesting way. A more trivial example would be like during development, you can use the tracking to basically measure how much certain blocks of code, how much gas they're consuming, or maybe compare, approaches to a problem by putting it in two different Rust functions, and then calling them, and then measuring how much gas each one is using, and use that as a way to sort of help optimize your gas footprint. So those are just two examples of what the gas tracking is all about.
Awesome. So you think this is something that we might see in the next mainnet upgrade, or is it something you would be implementing into Starshell wallet itself?
So those APIs exist now today in 1.9. They're live on chain. The only thing the only piece that's missing is the snip that I talked about, which is a way to standardize what the messages that go into these contract executions should look like as a standard, as well as a reference implementation. So we're working on that alongside sort of our own use of it for another project that makes use of opportunistic execution. And then so that's one thing. And then in addition to that, we're also finalizing the evaporation API usage. So there will be a snip amendment, a snip to X amendment for evaporation, which will apply to basically any contract that wants to take advantage of this extra layer of privacy, so that it can consume all the remaining gas if a user wants it to, in order to hide the true amount of gas that was used for its execution.
Awesome. Safar, Sean, did you guys want to add anything to that?
Just a big thank you to the Starshell team for helping us out here. Like, it's really fun getting ready to go PRs and just like proving them and ship them. So thank you guys.
Yeah, also anyone who's listening in right now, if you haven't downloaded Starshell Wallet yet and you're using Keplr, just download it and then have your mind be blown away by the difference. It's so beautiful. You will be so pleasantly surprised. Like, just download it right now and play around with it. You'll be excited.
That's exactly what I was about to say. I was going to say, just to wrap up this gas evaporation section, a plug for Starshell Wallet. If you haven't checked that out, definitely go check it out.
Yeah, and it's currently only works on Secret Network, and we're diligently working on expanding to the rest of the Cosmos. So if you're holding out, I understand, but definitely give it a download and try it out anyway. Once we are live on the rest of the Cosmos, we're being careful to not do that prematurely. Like we want our expanse into the rest of the chains to be very good already at the start, because if people start switching from Kepler and it doesn't have all the things that they want or whatever, they might not come back. So we're being very careful about the expanse into other chains. But if you're only, just using it for Secret Network, definitely give it a download, start using it. And every user helps us improve the product with feedback. So thank you very much.
Thank you, Blake. All right, we got a couple more features to cover. Got about 13 minutes left at the top of the hour, so let's run through these. We have execution finalization next, which is basically enhanced contract security. Soft, you want to take us through that?
Yeah, basically because on Secret you can use random numbers, you can basically do like interesting stuff. For an example that we saw in the past is that it's very easy to cheat on games. So, for example, on a dice game, let's say if I roll above 3, then I win, and if I roll 3 or below, then I lose. What a cheater might do is send the normal transaction message of like rolling the dice, and then in the same transaction, a message after, check their balance if they won the prize, and if not, then fail the message, which fails the entire transaction, which reverts the state of the game. So they can effortlessly like cheating games. They can also perform sandwich attacks on DeFi protocols, and I don't have like a quick example for that, but it's very like I wouldn't call it prevalent, but it's very annoying that as a contract developer you have to deal with like I can't do anything to prevent cheaters from doing annoying stuff, and then you have to design your contract to be a lot more complex in order to protect against these kind of attacks. So this finalized transaction feature allows contracts to basically use some sort of an API to say to the execution environment or to the chain, after I'm done, I want the transaction to be finalized, meaning no further messages can be executed after this contract execution in this transaction. And if despite of that a message is trying to execute, then the chain will fail the transaction. So effectively, like the cheater in the dice game example wouldn't be able to know if he won or not.
Nice. So basically, it allows the contract to say the transaction should end here and prevents a malicious actor from possibly inserting another transaction in between that might provide some kind of unintended outcome as far as the application developer intended. Or I guess another example would be something like a rollback attack where a malicious user would intentionally send a transaction that, let's say it's like a gambling app where if they get a certain number, they win some secret. And if they get the wrong number, they don't win. This malicious actor could craft a transaction that says if they get the correct number, they win. But if they get the wrong number, the transaction just fails. It rolls back. So basically, if they win, they get the secret. But if they lose, they don't lose the secret that they had initially staked.
They don't lose their turn. They can replay.
Yeah.
They can play until they win.
Right.
Maybe a simpler example is a paywall contract where you have to pay secret to get like some sort of secret information. And then what a malicious user can do is in the first message pay the fee and then get the get the information, and then in a subsequent message just fail the transaction, and then the payment of this secret is also rolled back, and I get the information and my funds back.
Yeah, that's a good example. John, did you want to add anything to that?
I think that was comprehensive. I'm looking forward to see some people try to hack the system.
Yeah, maybe we'll have some bug bounties around that in the future. All right, so we have a few minutes left, and we have one more feature we wanted to cover, the IBC emergency button, which is it provides improved emergency response capability. Sop, you want to take us through that one?
Basically it allows a multi-sig account to shut down IBC for the entire chain. And we designed this feature specifically for a scenario where a DeFi protocol on secret gets hacked, and the attacker will probably want to exit secret as fast as possible. So the fastest way is IBC and then probably centralized exchanges. So for IBC, for now, our solution is to add this panic button, which can be triggered by a simple transaction of, let's call it an admin account. And right now it's turned off. And the intended use of it is to have the admin account be a multi-sig of 7 or 9 ecosystem stakeholders.
So it could be like top validators or top IBC relayers, plus Secret Labs, something like that.
Yeah,
but it's configurable by on-chain governance, so it'll be up to the chain to decide.
Yeah, and right now it's turned off. Yeah, we'll draft a proposal soon. Like internally, we talked about finding stakeholders across all time zones because the last time the CeFi protocol was hacked, it took us about 20 minutes to turn off all bridges, but we didn't have IBC back then, which is permissionless, so that was lucky. Hopefully we won't have to use it, but it's there in case of an emergency.
Yeah, definitely a important thing to consider and a helpful feature to have. We definitely want to, keep our decentralized nature of the network, but since this is configurable by governance and it's not just a single person making the decision, it would be a multi-sig. I think that's something that most people would agree is a good thing to have and could potentially prevent something really bad from happening if there was an exploit on a DeFi protocol and somebody did try to move a lot of funds out of the network quickly. This would hopefully prevent that from happening. And I think there's another similar feature called IBC rate limiting that I think Osmosis uses it, maybe some other IBC chains as well. So I know there are some other options as well that people have come up with, but this one was a little bit different than that one. We discussed it on the forum a little bit, but we don't have a whole lot of time to go into that here. So I think we'll go ahead and wrap things up. Thanks everybody for being here. Thanks to our speakers, Asaf and Sean and Blake. Appreciate you being here today. Next week, I believe on Secret Spaces, we will be talking about Secret VRF specifically. So we'll do an even deeper dive on Secret VRF and all the potential use cases. And maybe we'll even have a guest who may be interested in using it, a dApp developer from the IBC ecosystem, not necessarily on Secret, but we'll see. So next Tuesday, make sure you come back and we'll be here again. Anything else you guys wanted to say? Soph, Sean, Blake?
Thanks so much for having us and excited to see what everyone builds in the cosmos.
But that also reminds me, we should be having some Hack Secret results coming out soon, hopefully next week. Definitely within the next couple of weeks. So keep an eye out for that as well. I know there was some pretty cool submissions.
Definitely. Thanks, everybody.
Thank you. Thanks, guys. Bye.
Thanks, guys. Have a good one.